you can get more than one triangle or no triangles to occur. Maybe Seb might have mentioned that. I know when we did law science in my class, I did say that does show up. I'm not going to get into this, what we call ambiguous case today. I'm just going to walk you through how you do the setups of the algebra and all that. Now, the idea of the law of signs is that we use the law of signs when you don't have a right angle. Okay? You use the law of signs when you don't have a right triangle. And you know an angle and its opposite. Okay. Basically the idea of when you're using law of signs.
So that little
The law of signs is the showdown.
Oh,
you did that?
Yeah.
Wait,
I thought somebody's phone was going off. I was like, wow.
that's what I thought too.
Why do you do it?
It was music.
Then I heard whistling. I thought it was like.
Well, it's when he like clicks it.
So when you're talking about law of signs, you obviously have three sides, three angles. Angles are always given with capital letters. Side opposites are going to be the lowercase of them. Okay?
But
Convenient
all
how it
C's
works.
look the same.
Wait, what is that?
Right?
Hey, Mr. Murphy, what is that thing? Angle.
That's right. You guys didn't have me, so you didn't know what that means. This is the angle symbol. I use that as an angle symbol. The reason I use this is because this looks like less than or a really bad L. Bless you. So when I was in high school, my teacher, Mrs. Bender, banana, pentacle, bender, knee, whatever. She drew this arc in it to designate it as an angle. So, anyway, law of signs was basically a proportion. It's the ratios of the sides and the sine of the angles and the sides opposite. So it's the sine of angle A is to its side opposite, is the sine of angle B to its side opposite, the sine of angle C to its side opposite. Law of signs is really very easy to use. It's very user friendly. What you need to have though, in order to make it work, is you have to have an angle with its side opposite, because if you don't, it won't work. Okay? If you don't have it, it won't work. Yes, ma'am.
So like, does that mean that the sine of angle A over A is equal to the sine of angle B over B?
Yep.
Okay.
So, when this scenario will happen is when you'll have two angles and a side, or you're going to have two sides and an angle. But one of those angles has to be across from one of the sides. Now, obviously, if you have two angles and a side, you can find all three angles, because what do all three angles have to add up to in the triangle? 180. So, law of signs is pretty straightforward. So what we do here a lot of times is you're just going to get values. You're not going to get a diagram or anything like that. So you just need to draw it. So all you do is draw a triangle. Does it have to look like it has a 103-degree angle in it? Nope. Does it have to have three sides?
Yes. Yes. It's not a triangle.
Okay. Suggestion that I've been making, or I make for this type of stuff all the time, is that obviously you're going to have 3 of the 6 parts that you need to know to solve it. So label what you have. I know that angle C is 103. I know that angle B is 28. And side B is 26. Now, according to my diagram that I have made now, I need to find 3 other parts. I need to find angle A, and little c. So what I'm doing here is off to the side of the problem is I'm labeling the other 3 pieces that I need to solve for so I don't forget them. Because I'm not going to say, oh, what is side A? What is side B? What is angle A? I'm just going to say solve the triangle. And you need to figure out all the parts that are missing. Okay? Obviously, the easiest thing to do here is to find A first. Well, 180 minus 103 is 77. Subtract 28 from that, and you get
49.
very good. So we know our first part is going to be 49. Now, the next thing that I normally do when I'm working with law of sines, or eventually we get to law of cosines, is that I like to circle the angle and the side opposite. The reason that I do that is because I'm going to reuse that one to solve for the other two pieces, the other two side lengths in this case. Because that stuff is given to me. I can't screw that up if they gave it to me. But if I reuse another side or another angle measure that I had to solve for my own, I could have screwed that up. So by reusing your givens a lot of times, you're going to be less likely to make a double mistake. You'll see what I mean here as we get going with these. So I write it out. Sine 28 is to 26, as sine of 49 is to A. Do it again. Sine of, 28 is to 26, as sine of 103 is to little c. And now you're at a basically works out to be a two-step algebra problem because you have fraction equal fraction. So when it's fraction equal fraction, what do? Cross multiply. Okay. And in due time, you'll probably start to pick up on some shortcuts that you'll be able to do. So I'm going to get 26 sine 49 is A sine 28. Try to bring it back. So here's my other suggestion for you guys. Each and every single one of you guys has the alpha y equals button, which creates a fraction. Use the fraction bar, guys, because every time you press the sign button, a parenthesis opens. If you don't forget, or if you forget to close the parenthesis, you're gonna be wrong. Okay? But if you use it as a fraction bar and forget to close the parenthesis, you're gonna be okay. So type it in just like you see it here. Also, notice I'm writing down what I'm going to type in. So I'm going to do my alpha y equals. It's my sideband from the alpha window 5s. And there's my missing side length. Okay.
You're in radians.
Oh, I'm in radians.
Of course you are.
Silly herpes.
You said to be
No, ours definitely not supposed to be.
I already know what that means.
Radiant? You haven't learned yet.
Okay.
There we go.
Got it. Shiver me to
That's
death.
why I was having so much trouble.
No, it's like, my brain, my eye is so tired, guys. This one's about to fall.
So this gives me an angle, or excuse me, a side length. 4179.6 goes 41.8 when I run two decimal places. Okay. That gives me little a. Now I do the exact same thing to find little c. 26 sine 103 is c sine 28. Bring the 28 sine 28 back. $53.96. And now you've got all these decimal value numbers. How do you know if it's even right? You can't use Pythagorean theorem to check it. You can't do anything.
Oh my god.
She got an eye patch. We made her an eye patch. I felt bad for her. Did you ever show them the eye patch?
Huh?
No worries. No problem. See you. I hope you're coming back. She's like, bye, see ya. I'm like,
All of our stuff's here. She's got to come back.
I know. We should all leave real quick. It'd be funny.
You should hide her calculator, make her feel like she's
So,
supposed to.
Our little a was what? 41.8. And there was 53. Now, does it look like it makes sense though? Do you remember the rules about angles and sides opposite? This is not a right triangle, so that won't work. So, what is it?
Biggest angle is biggest side.
Correct. Remember, the largest angle will always be across from the longest side length. It's one of those properties in geometry with triangles that has to hold true. So we look at it as, I mean, that's about as best as we can do sometimes with law of sines is, does it make sense? Okay? Change does. Changes sense. Yes, sir.
Does that also mean that the smallest angle is across the next smallest side?
Yes, sir. It just goes in that, it goes in order. And what happens if the two angles are the same?
Then they're just at the coincidence.
Which means it's a no. It's a sex opposite. Okay, try it again. So you start with what you know. A lot, yeah. So, thank you. I forgot this was on that. Do I have an angle and a side opposite it? Yeah. Which means now I can go ahead and solve. So, what am I going to solve for first? Angle A. Very good. The reason I'm going to solve for angle A first is because I have side opposite angle A. Okay? Now, real fast. What kind of an angle is 122?
A big one.
Obtuse, which means that its supplement would have to be acute, right? Okay. Whereas if I had an acute angle, its supplement could be obtuse. This is where some of this, what we call ambiguities, will come into play tomorrow. What happens is, within the law of sines, you do run the risk of possibly having multiple triangles. And the reason that happens is dependent upon the angle that you start with. If the angle you start with is an acute angle, and then the next angle you end up finding still has a supplement to it that would still work, you could bounce into two different triangles. The reason that that happens is because of trigonometry that you haven't quite learned, but it's not a real big need to know right now for a law of sines. I alluded to this yesterday. Positive, positive, negative, positive. Remember that?
Yep.
And I said that all trigonometry is built off of the three angles.
Yes.
And remember I said which one was the ordered pair? It was like, which one came first, cosine or sine?
Cosine.
Cosine. Cosine and sine are your ordered pairs. So here, cosine and sine are both positive. What's positive, negative here? Negative. Now, if this is at 0 degrees, this is at 90 degrees, this is at 180, that just means that I can get a sine value of an angle that is still positive, that is greater than 90 and less than 180. Which means that I could have triangles with side lengths that can bounce within the two quadrants to overlap with an obtuse angle. It's kind of cool how it actually works when you get into the real trigonometry of it, but I don't teach it that way. I like to go off of just, this is the rule, this is what I want you to do, because it's more just, it is more or less pressing buttons. I'm trying to get all the button pressing out of your system so we can start doing things like this. All right, so sine of C is to its side opposite, as the sine of angle A is to its side opposite. Is there any reason for me to have to multiply the other side by 18?
Nope.
No, right. Because I'm going to just have to divide it back anyway. So you'll start to pick up some shortcuts. So I'm going to get 12 sine 122 over 18 is the sine of A. And now I want to make sure you know how to press the sequence of buttons. We do the same thing, alpha y equals enter, to get our fraction bar. 12 sine 122 over 18. And I hit enter. I get some crummy decimal. Okay? I get some crummy decimal. Well, do you remember how to undo sine of an angle? What was it? Very good. So right now, with this decimal in here, all I have to press is second sine of my answer, and there's my angle, 34.43. Okay? That gives me my other angle. So then what would you do to solve for angle B? And unfortunately, there are times that you have to reuse what you just solved for. So you kind of hope that you did it right. So what do you get? 23.7. And then you reuse that to get the next one. So it'll be sine 122 over 18. Sine 23.57 is to little b. And you just get some values. And you're pressing more buttons. Yes. Yeah. All law of sine stuff, basically anything that's right triangle trig and law of sines, law of cosines, it's going to be in decimals. We're not going to worry about, I mean, there are some of them that you have the 30, 60, 90s, things like that. We'll worry more about that stuff when we get into radians and we start dealing with the unit circle stuff. Because then it's all going to be fractions and it's all going to be, you're going to be living in fraction town for a little bit of time. Oh, yeah, fractions are fine. Don't get, what is toilet paper, because we didn't have any Kleenex. So
Are you throwing it away?
I thought somebody was being obnoxious.
You're being obnoxious by interrupting class.
Now, there are times that I might say, hey, what would this wind up being via the setup without pressing buttons? And I do that too. Yes, sir.
Is this going to be on your website tonight?
Yeah.
Okay, because I'm going to watch the first one, then I'm going to watch this, then I'll watch the first one again. Maybe I'll...
This is all, everything you did last year in chapter 7 is geometry. We're doing it in like a day and a half.
I think, okay. I got to
Tomorrow, we'll get into the ambiguous case, and we'll do more of those styles. The problems that I have for you, I think, I forgot what numbers they were.
That's a lie.
It's in 13.5. I forgot what page it was, but there's only 5 of them.
Huh?
24/7.
I know. And then you're talking
Is it 802 or 803? 803. Page 803.
Never mind.
I want you to do those 5. You're solving the whole triangle, so you're going to solve for all 3 missing parts. Each and every one of those 5 problems will work, and there will only be one triangle that will be able to be created with those values. We will spend the day tomorrow discussing how you can decipher whether or not you need to worry about a secondary triangle. It sounds like it's really, really weird, but I've come up with a really nice shortcut to make it work cleanly. And it's a matter of just looking for a supplement. And it really is. And what are supplements? What are two angles in your supplements? What do they add up to? That's all it is. If you can do that and visualize and write something down and cross-reference things, you're going to figure it out real quick. Because how many degrees are in a triangle? What? Listening is good. Cut the hair off with your ears and I hear better. Which one?
Can you go back to the first triangle that we saw?
Which one?
Like the very first one we
Just
saw.
right, just like start saying.
Yeah, but like the one that actually had numbers and stuff.
Oh.
Yeah. Where do you get?